water is passed through a tube to a tank where coagulation and flotation occurs. Coagulation is a process where chemicals like alum, which is known as coagulant, is added to the impure water so that the small particles are bind together in large amounts, and the water is then passed through another tank where sedimentation occurs. The water is allowed to sit in the tank, and the impurities are set down at the bottom of the tank. Then it is passed to the tank where filtration occurs. Actually, filtration is the main stage. First, the contaminated water passes through rocks, then through coarse sand, then it reaches charcoal. Charcoal is the activated carbon we have used in this treatment. Charcoal absorbs the impurities, and then it is passed through, the water is passed through sand, and then through a cloth it is taken to a container where pure water is collected. So we are going to now present the prototype of distillation of water. Actually, distillation is a separation process where impurities from water is separated, given that the boiling point of impurities is less than that of the water. So I will give you a brief explanation about the apparatus. So the mixture to be separated is heated using the burner, where the steam is collected in a condenser and it is condensed to form pure water, and it is collected by a beaker. That's it.
Topic for this project is catalytic reforming for pure application. So I am here to give a brief explanation about what is catalytic reforming for pure application. Catalytic reform is a critical chemical process that used in petroleum industry, used for the enhancement to enhance the quality of gas lines and petroleum products. It involves the transformation of low octane naphthalene to high octane naphthalene, which is a valuable compound used in the petroleum industry. It not only improves the quality but also increases the yield of aromatic hydrocarbon, which are major components used in petroleum chemical feedstocks. The key components of the reaction in catalytic reforming is feedstock, catalytic reactions, and operation condition.
മോട്ടോർ മാഗ്നറ്റിക് സെർവോയിട്ട് മാറ്റിയത് അത് സപ്പോർട്ട് ചെയ്ത് എന്താ ഹീറ്റിംഗ് ഫാനാണ്. ഇതിൻ്റെ പേരിൽ കാണാൻ പറ്റും ഒരു ടീ ഷേപ്പ് അതാണ് സെൻസർ. അത് യൂസ് ചെയ്യുന്ന സെൻസ് എന്താ ആ ലിക്വിഡിൻ്റെ ടെമ്പറേച്ചർ pH ഒക്കെ മെയിൻറ്റെയിൻ ചെയ്ത് അത് ടെസ്റ്റ് ചെയ്യാൻ വേണ്ടി ബാക്കി വർക്കിംഗ് ഉണ്ട്.
Hi, myself Sean. I'm in explain operations of bioreactor. First, we will introduce a microorganism or cell into the container. After that, we will fill the container with nutrient-rich solution, and we will mix that solution with lactic sterol that you see inside the container. And after that, we will maintain the desired temperature using a heating pad or water pad that you see at the bottom of the container. And the culture is allowed to grow under specific conditions, and after that, once the desired growth is achieved, we will collect the biomass or product through this.
Good afternoon all. This is our project, and its name is F1 treatment plant. So our team members are Ashwin, Nitin, Anand, Anush, and me. So without any further ado, I will give an explanation about this. F1 treatment plants are crucial for treating wastewater before it is discharged back into the environment.
ഇതിന് മെയിനായിട്ട് 3 ട്രീറ്റ്മെൻറ്റ്സ് ആണുള്ളത്. പ്രൈമറി, ടേഴ്സറി, സെക്കൻഡറി, അങ്ങനെ 3 ഡിവൈഡ് ചെയ്യാം. പ്രൈമറിയുടെ നമ്മൾ ആദ്യം വലിയ ഇത് ഫുൾ വേസ്റ്റ് പാർട്ടിക്കൽസ് റിമൂവ് ചെയ്യുന്നതാണ്. ആദ്യം വലിയ പാർട്ടിക്കൽസ് റിമൂവ് ചെയ്യുന്നു, പിന്നെ അത് അതിനുള്ള സ്ഥലത്ത് അങ്ങനെ പോകും. പ്രൈമറി, സെക്കൻഡറി, ടേഴ്സറി. പ്രൈമറിലെ സോളിഡായിട്ടുള്ള വേസ്റ്റ് റിമൂവ് ചെയ്യാം. ഇത് സ്ക്രീനിങ് മെത്തേഡ്, അതുപോലെ സെഡിമെൻറ്റേഷൻ വഴി നമുക്ക് റിമൂവ് ചെയ്യാൻ പറ്റും. അവിടെ നേരെ വാട്ടർ വന്ന് സ്റ്റോറേജ് ടാങ്കിലോട്ട് ഡെപ്പോസിറ്റ് ചെയ്യും. അവിടെ നിന്ന് അണ്ടർഗ്രൗണ്ടിൽ കൂടെയാണ് പൈപ്പ് കൊടുത്തേക്കുന്നത്. നേരെ ഗ്രിഡ് ചേമ്പറിലോട്ട് വരും. ഗ്രിഡ് ചേമ്പറിൽ നിന്ന് അടുത്ത മൈക്രോ പാർട്ടിക്കൽസ് ഈ ഗ്രിഡ് വഴി പാസ് ചെയ്ത് ക്ലീൻ ആവും. അവിടെ നിന്ന് വരുന്ന വാട്ടർ നേരെ ക്ലാരിഫയറിലോട്ട് പോകും. ഇവിടെ ഇത് റൊട്ടേറ്റ് ചെയ്യുന്ന കൂട്ടത്തിൽ അനേറോബിക് ബാക്ടീരിയ ആക്ട് ചെയ്ത് സ്ലെഡ്ജ് ഒന്നടിയും. ബാക്കി വാട്ടർ ഇതിലെ കൂടെ എയറേഷൻ ടാങ്കിലോട്ട് എയറേഷൻ ടാങ്കിൽ ഡിസോൾവ് ആയിട്ടുള്ള ഗ്യാസ് ഉള്ള അങ്ങനത്തെ വേസ്റ്റ് നേരെ വാട്ടർ പമ്പ് വഴി അത് ഡിസോൾവ് ആവും. ബാക്കി വാട്ടർ പമ്പ് വഴി സാൻഡ് ഫിൽറ്ററിലോട്ട് പോകും. സാൻഡ് ഫിൽറ്ററിൽ നിന്ന് ഫിൽറ്റർ ആയിട്ടുള്ള വാട്ടർ നേരെ റിസോഴ്സിലോട്ട് പോകും.
Hydrogen storage tank provides decarbonized alternatives for domestic heating, because liquid hydrogen must maintain an extremely low temperature of minus 59.5 degrees Celsius to avoid turning into gaseous hydrogen. The entire design of a hydrogen tank is used to prevent the heat intake. The hydrogen storage tanks are usually spherical as opposed to cylindrical tanks for the minimal interaction between the tank and the outside walls, and less interaction means less chances of heat intake. Now the process is basically the tank is filled with water, which consists of hydrogen and oxygen, and electrolytes such as salt is added to increase the electrical conductivity of the water. The power supply and electrical current is supplied to the water through metal electrodes, splitting the water into bubbles of hydrogen gas and oxygen gas. The hydrogen produced is the way of storing excess electricity, being stored underground in empty cells, gas caverns or salt bombs. It can be also used for alternative fuel sources of transport and heating, as well as in feedstocks of chemical reactors. And the components of this liquid hydrogen tanks are, this is the inner wall and it's having a thick outer wall. This thick outer wall is maintained to suppress the pressure and the temperature inside this tank. And we having two suspensions on the two sides. And the liquid hydrogen is inside, and which is of the temperature minus 253 degrees Celsius. And this is a safety valve. And we having a reversing valve, which is gaseous or liquid state. And then cooling. This is a cooling water heat exchanger. And this is the components of the liquid hydrogen storage tank. Thank you.
Hi, we are here today with a simple model to show how an MBBR works. MBBR, commonly known as moving biofilm reactor, which is a modern technique to treat waste or sewage water. It is very useful in removing biochemical oxygen, demand nitrogen and ammonia from the wastewater. So when we look at the working of this model, like I said, this is a simple moving biofilm reactor model. So the sewage water is first collected in the aeration tank. These aeration tanks are lined with air dispensers at the bottom of this tank, and these air dispensers are connected to blowers which are placed outside of the tanks. In the aeration tanks, with the proper aeration, after proper aeration is done, this helps in removing the purity level of the water by a very huge amount. And after proper aeration, the water is let into a MBBR tank. In the MBBR tank, we introduce MBBR media or biofilm media. These biofilm media are made up of plastic or PVC like things. These plastic media helps in the accumulation of bacteria or microorganisms, which further helps in the which further provides surface area for the accumulation of these bacteria, and these bacteria helps in breaking down organic matter present in the sewage water into simple molecules. And after the breakdown of this organic matter, the water becomes less pollutant free. And after proper treatment in the MBBR tank, after a certain amount of time, this water is then let into a lambda clarifier. While letting the water, these MBBR tanks have a retention caps placed inside them, so that the biofilm media does not enter the lambda clarifier. So in the lambda clarifier, we have inclined plates, which are the inclined sheets, which are which helps in the settlement of sludge that is accumulated by the MBBR process, and this sediments get deposited at the bottom while the water moves above. And after the proper clarification, the water is then let into the collection tank, and according to our needs and requirement standards, this water is then purified and filtered by various other means like carbon filtration and all, and this is used for taken for every use.
This is the conversion of waste materials into English pyrolysis means in absence of oxygen, they are converted into they are burned in 300 to 600 degrees Celsius. In this consists of feedstock preparation, pyrolysis of reactors, condensation system, gas collection system, gas collection system, refinery system, control system, and the environmental system. In feedstock preparation, in this, the plastics are placed according to their own size, and in pyrolysis reactors, it burns in 300 to 600 degrees Celsius in absence of oxygen. And in condensation system, that either liquid form is condensed and cooled. In gas collection system, the condensed form, there is lots of gases it is collected inside the gas collection system, and the separation of gases is also done in gas collection system. In gas collection system, it consists of solid wastes that is formed inside the condensation system. It is collected in gas collection system. And the refinery system is used to collect all the fuels like petrol, oil, kerosene, inside in that is coming from the condensation system. In order to control all this system, there is a control system inside. Control system helps to control all the reactors, feedstock, condensation system, gas collection system, refinery system. It helps to shut off our system when there is any problem occurring. In environmental control system, if anything harmful gases like will be produced, if it is goes outside the reactor, environmental control system helps to shut off the whole of the reactors. This is our pyrolysis waste plastic, conversion of waste plastic into fuel. In this, the benefits are energy conversion is the major